Hi guys, today we're going to learn about functions. So in this section I will determine if a graph is a function by using the vertical line test and the definition of a function. And I will go over independent and dependent variables. So let's go over the definition of a function. So what is a function? A function is a rule that produces, so the definition, so this is the textbook function. A function is a rule that produces a correspondence between two sets of elements such that to each element in the first set of three corresponds one and only one element in the second set. So what they're saying for that is that you cannot have an x value that repeats more than once. The first set is called the domain, and the set of all corresponding elements in the second set is called the range. So x is the domain and y is the range. The variable x is also called the independent variable, indicating that the values can be assigned independently to the x from the domain. The independent variable is also known as the domain. That's self-explanatory, right? And then the variable y is called the dependent variable, indicating that the value of y depends on the value assigned to x, and on the given equation. So the dependent variable is also known as the range. So that's pretty self-explanatory. The domain is the x, or also known as the independent variable, and the y is the dependent variable, also known as the range. So now the next step is, so you found out what is the definition of function. So how do you determine if it's a function? So there's another way you can determine if a graph is a function. So you can do what's called the vertical line test for a function. So if any vertical line passes through two or more points on the graph of an equation, then the equation does not define a function. So what they're saying is, if you put a vertical line of a graph, and if that vertical line hits it more than once, then it's not a function. If it only hits it once, then yes, it's a function. And then a function cannot have the same x value more than once. It must also pass the vertical line test. Let's do actually an example. So here's an example, my first graph, y equals x squared. So it looks like a typical parabola. And so yes, this is a function because there's two reasons. It passes the vertical line test, it just only hits it once. So yes, that does that. It passed the vertical line test. Also, if you look at the these 2 points, 1, 1 and negative 1, 1, notice the x value 1 and negative 1, they're not the same. They don't repeat, so it's definitely a function. What's not a function is, let's say you're given this graph, x equals y squared. If you were to graph it, it would look something like this. So it's not a function because if you put a vertical line test, notice that it hits it more than once. So it hits it here once, and then another time over here once. So that's a total of 2 times. Also, if you were to look at the domain, if you were to look at these points, and if you were to look at the domain, the x values, you have a 3, and this should be a negative 3. I mean, sorry, this should be positive 3, excuse me. They're both the same, right? 3 and positive 3, they can't have the same x value, so that's why it's not a function. So let's recap of what a function is. So, recapping, so a function cannot have the same x value more than once, and it also must pass the vertical line test. So if the vertical line passes more than once, then it's not a function. Good. So and then x value is the independent variable and y is the dependent variable. So now you know what is a function and what's not a function. We can actually do some problems. So my first problem says, is this a function? Now this one does not have a graph, right? It does not have a graph. You got to determine if it's a function. So let's see, we have a domain here. The domain is like 1 to 3. So how you can say this is, you can actually write it in a point. So 1 goes with 3, so you can rewrite that as 1 comma 3. Now this 3 goes to 5, so you can rewrite it as 3 comma 5. And then this 3 also goes to 7, so you can write 3 comma 7. And then this 5 here goes to 7, so it's 5 comma 7. And then this 5 also goes to 9, so it's 5 comma 9. As you can see, it's not a function. Not a function. Do you see that if you were to look at these points, the x values, we have a 1 here, 3 here, a 3 here, and a 5 here, and a 5 here. Notice that those 3's and those 5's repeats it more than once, so that's why it's not a function. Since x value repeats more than once. Good. So that's that one. Okay, so the question is, you're giving points, right? Coordinates 0, 1, 1, 1, 2, 1, 2, 1, 3, 2, 4, 2, 5, 2. So the question says find the domain and range. Is this a function? So first let's find the domain. The domain, remember, is always just all the x values, so we can write the domain like this. So yeah, it's just pretty much all the x values. So it's 0, 1, 2, 3, 4, and 5, right? So it's 0, 1, 2, 3, 4, and 5. Now let's figure out the range. So remember, the range is always the y value, so we have 1, 1, another 1, 2, 2, and 2. So that's my domain and that's my range. Now, is this a function? So let's look at the x values. Does it repeat it more than once? 0, 1, 2, 3, 4, 5. No, right? It does not repeat it, so it's definitely a function. So yes. But you're probably thinking, well, what about the y value? It repeats it more than once. Yes, but we will go later on this section, and that's called, if it's called an inverse, that's called a one-to-one function, but we'll go over that for the next section. So basically, yeah, we'll go over one-to-one function, but right now we'll just focus on a function. So yeah, a function cannot have the same x value, so this one is definitely a function because it does not repeat on the x values. Okay, so let's do this problem. I think this is going to be one of the shorter videos. Now, we're given like graphs, so we got to figure out, are these a function? So let's look at this one, this linear equation graph. Is this a function? Let's see. I don't have the domain, but I could do what's called the vertical line test. Now, if it only hits it once, then yes, it's a function. So this only hits it once. So this one's yes, definitely yes. What about this weird one? If I let me, I don't have the domain, so but I could still figure it out using the vertical line test. So I'm going to put a line through it. Over here, it just hits once, and then twice, and then a total 3 times. That was a total of 3 times it hits. So is this a function? No, because it can only hit it once, not a function. What about this one? Now this one is a it's still technically linear graph, but it's completely vertical, and I'll call this graph x equals 3. So if I put a vertical line test, it passes here, but like what about here? It's a big no, because it's hitting it all the way. It's more than once, right? It's here, 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 here. So no, it's a big no, not a function. Okay. So that was, now let's actually do some okay, so let's say we're given 4 different functions. F of x equals 2x plus 6, big F of m equals 2m squared plus 3m minus 1, gt equals 3 minus 2t, and then big G of u is u squared plus u minus 1. So how do I find f of negative 1? So remember, this negative 1 is like it's like an x value. You're putting this x value into this function, and you're going to get a y value, which is the whole thing. So here's f of x. When you plug in negative 1, wherever you see an x, you're going to plug in negative 1. So it's going to be 2 times negative 1 plus 6. Simplify that. That's negative 2 plus 6. And then 6 minus 2 is positive 4. Right? So what you're saying is, if you wanted it in coordinate form, remember this negative 1 is my x value, so it's going to be negative 1, and then whatever is the outcome is your y value, so your outcome is 4, so it's going to be negative 1 comma 4. So that's how this one. What if I wanted to find big G of 2? So here's G, the G function. You're going to plug in 2 into the U, and then you're going to get your y value. So wherever you see U, you're going to put 2. So it's going to be 2 squared plus 2 minus 2. When you put that all together, you get 4 minus 4. You're going to get 0. So when you plug in 2 into the G function, you're going to get a y value of 2. And then if you want it in coordinate form, it's going to be 2 comma 0. Right? Not too hard. What about this one? Big F of negative 1. So let's see, where's my big F? Right here. You're going to plug in negative 1 wherever you see an m. So it's going to be 2 times negative 1 square plus 3 times negative 1 minus 1. When you put it all together, let's see, 20. This one is, so negative 1 squared is positive 1, and then you times it by 2. 3 times negative 1 is negative 3, and then minus 1 is negative 4. So it's like saying 2 minus 4, that's still technically negative 2. And then if you want it in coordinate form, remember this negative 1 is your x. It's going to be negative 1. And then your y value is always your outcome, so it's going to be negative 2. And then what about this weird one? You have 2 big F of negative 2 minus G of negative 1. So let's figure out, where's my F? Here's my F. My big F is this one. And then my G is this one. Right, so remember those two functions. Now what they're saying is you're going to plug in big F of negative 2 minus G of, and then you're going to put a negative 1, and then you're going to multiply that whole thing by 2. So let's see. I'm going to put a 2 here, and then I'm going to multiply it by this F of negative 2, so I'm going to put a bracket. When you plug in negative 2 into big F, you're going to get 2 times negative 2 square plus 3 times negative 2 minus 1, and then close that bracket, and then it's going to be minus, and I'm going to put another bracket because I have to distribute this negative, right? So when you put in -1 into big G, right, that one, u squared plus u minus 2, you will get -1 square minus 1 minus 2, close the bracket, you're going to get, okay, so let's focus here. -2 squared plus times it by 2 plus 3 times -2 minus 1, you are going to get bracket 8 minus 6 minus 1. And then that simplifies as that's going to give you just regular 1, right? Minus, and then let's focus here. -1 squared is +1, minus 1, minus 2, and that should give us 1 minus 3 is, that's like saying 1 minus -3, which is -2, right? Okay, so we're almost done. Now I gotta distribute that negative, so it's gonna be minus a minus 2, and then 2 times 1 is +2. And we all know that when you have two negatives, they become positive, so your final answer is 4. Okay, so that was that one. I think we have one more. Oh yes, we have one more. Okay, so they give us a graph of this, right? This weird polynomial. So this is not in scale. So yeah, this is not in scale. So what are they saying when you have y equals f of -4? So what is that really saying? So what you're saying is when you plug in -4, remember this is an x value, what is my y value? That's what they're saying. So let's look at the graph. Now remember this is not in scale. So let's go at our x value of -4. So -4 is around here. This is like -4. So what would be my y value? Now my y value, this is not in scale, so that they said the highest is 10, so this is about 7. Yeah, so your answer is just 7, right? Because you're plugging, what they're asking is, you're plugging -4 as an x value into this function. What is my y value? And your y value is 7. Okay, so, oh, sorry, I missed a problem. Let's see, it was the last problem. Yeah, this one. Wait, nope, not this one. This, yeah. Whoops, this is not part of it. So yeah, you're given 4 functions. F of x, these 4 functions, right? Now my last one, the one I skipped, it should be this one. Let's say you're given f of 0 times g of -2 all over big F, and you're going to plug in -3 into that function. So remember, so here's our 4 functions. Here's f, here's small g, and then you're going to plug in -2, and then here's big F right here. So basically, when you plug in f of 0, you're going to get 6. And when you plug in g of -2, you're going to get positive 7. And then when you plug in, yeah, I think I went a step fast. So let me show you how I got 6 when you plug in f of 0. So when you plug in f of 0, you're going to get 2 times 0 plus 6. And that gives us 6. And when you plug in g of -2, you're going to get 3 minus 2 times -2, which is 3 plus 4, which is 7. And then when you plug in f of -3, because you're going to divide this, right? You're going to get 2 times -3 square plus 3 times -3 minus 1. You're going to get 2 times 9 minus 9 minus 1. And then you're going to get 18 minus 9 minus 1, and you're going to get positive 8. Whoops, too fast. So over here, we got 6 times 7, which we got it from here, and then f of -3 is positive 8. And when you do the calculation, you're going to get 42 over 8, or you can rewrite that as 5.2 in decimal. Okay, so that wraps it up for this section.